Hey guys, welcome back to AlgoYogi, and let's solve binary tree level order traversal. So from our AlgoYogi, let's go to the problem on LeetCode. It's a really simple problem, one of my favorite problem. Uses breadth first search. I love that algorithm because it's so easy to implement and so easy to understand. So given the root of a binary tree, return the level order traversal of its nodes, node values, from left to right. Basically it's trying to explain to us, but we already know what a level order traversal is. So given this binary tree, in the output we see it's giving us a two-dimensional list, which is level by level from left to right. That's where our values are. So this is 3 is over here in the first level, second level 9 and 20, which is over here, and 15 and 7, that's over here. So let's try to understand how we're going to solve this. So given our first example, this one, so we're going to iterate over our binary tree using levels. So this is level 1, this is level 2, and this is level 3. And here on our first level, we're gonna add that value to a list, and in the second level we'll be adding those values to another list, and then on the third level we'll be adding all the values from left to right to our third list. And the way we'll be returning all of the list is as another list of list, and that's it. That would be our answer. How are we going to solve this problem? Using an algorithm called breadth first search. So in BFS, we use a queue data structure, and initially queue will contain the root node. So in this case, my queue first contains 3, and then I basically keep checking in a while loop if my queue is non-empty. If it is non-empty, then I basically pop out the first value from my queue and process that. So if I'm popping out 3, then my current node 3, I will be basically going to its left and then its right. So I'm gonna process its left and right, and in order to process that, I'm just gonna put it onto my queue. So I'll put 9 onto my queue and 20 onto my queue. So now my queue has 9 and 20 that I need to process, but currently I'm processing 3. And what I mean by I'm processing 3, that means I'm processing all the nodes of level 1. So I'll basically take a snapshot of my queue when I'm starting it. So on level 1, so I'll call it LQ. Sorry, level queue. Let's call it LQ, which will take the snapshot of 3, and this is what I'm going to place it into my answer as well. So my answer will contain currently as 3. So I'll process that like adding it to my list and then appending it to my answer. Now this is done processing. Now I again go back to processing 9 and 20, but this time also I'll take the snapshot of this queue and this queue, so which will be 9 and 20. This is what I need to process, and I'll empty the first queue. And then I'll start processing this queue by pulling out first 9. So I'll pull out 9, and then, sorry, not queue, 9. I pop out 9. Oh my god, I think it's just really sexy to write queue. Never mind. But so I pop out 9, then 9 doesn't have anything, so this is done processing. Then I pop out queue 20, and then I see basically it has left and right, so I put both of them here, and then I basically done processing this LQ, level Q, and basically I was supposed to add that to my answer as well. When I took this snapshot, I'll add the values list to my answer that I will be finally returning, and then I'll place this queue. I'll take the snapshot of this queue, and then I'll start processing that. But Before that, I'll just add that to my answer also. And then finally 15 I'll process, nothing is done, so this is empty right now, and there is nothing to add basically after I'm done processing 7, because they don't have any children to process. So finally I will return the answer. So let's write down the solution. And I said we'll be using queue, but I'll be simply making use of stack, because I can add value from the back and pop out the value from basically the 0th index. So same thing. Why make our life complicated if queue also is a data structure that's basically created using array and stack, list, basically all of them. They're just same thing. Is just there's some abstraction that's added. However, let's write out our solution. So I'll have answer as my main list. Then to my main queue, I'll be adding the root, and I'll say while queue, I'll assign queue to my smaller queue, and this is where I'll have my level list, which will be empty currently. But for node in my queue, I will basically add if so node will exist, so node's value I'll add it to my level list dot append, and that will be node dot value. And now depending on if my node has left and right children present, I'll append them to my main queue. Remember, I'm appending them to my main queue, not this small queue. Small queue is the snapshot that we talked about. I took the snapshot, I'm processing that snapshot in just one for loop, all of them, and I'm basically going through all the nodes in that snapshot and appending them as a list to my answer, as well as I am checking if they have left and right children present. If they have, I will append it to my main queue. So in the end, it's the main queue that I am basically processing. This is just a snapshot. It's the chunk of that this entire queue that I'm taking. Later I'm basically I have to create it as a fresh queue as well. So I have to assign it empty now, because I'm done processing these queue. These are the fresh nodes that are coming on the next level. Okay, so initially it was 3. Initially it was, let me just show you guys. Initially it was 3 on my queue. Then I took the snapshot, created this empty queue again, and then when I'm processing the both child 9 and 20 of sorry, I'm processing 3, then I'll check if it has left and right, and as per that I will basically append it to my main queue. And same thing I'll do for my, let me just focus here again, and same thing, if node dot write, then I'll append my nodes left to my main queue as well. That's it. That's the entire logic here. And once I come out of this for loop, processing this small snapshot of the queue, I have that levels value here that I want to append to my answer, because at the end of the day that's what I will be returning. And that's it. Not like that. Append it. And finally let's just return answer. Okay, so let's go over it again. I assign my root value to the queue. I assign root value to my queue, and then I am basically going into a while loop. where I'm checking if are there nodes that I need to process in the queue, and if there are, I basically take the snapshot of that queue and assign that queue as like an empty array, because this is what I'll be processing. I'll process all the nodes. I'm not leaving anything behind. And then I create this empty list for that level list and process all the nodes. While processing, append all the value to my list and given and check if they have left and right child. You don't want to add null nodes to the queue, and if they are, then just add them to the main queue, and main queue will be processed on the next level. So this is really simple solution. Let's try to run it. I hope it's yes, of course we don't want to process the none type node. So if we come across the root is none, then we just want to return empty string, the empty answer. So let's try to run it, and voila, let's try to submit the answer. Okay, really 7%. Anyway, it's accepted. Time complexity would be big of n because we're processing n number of nodes, and space complexity will also be big of n, placing them in our queue or the answer. Anyway, it's done, and let's go back to AlgoYogi, mark this problem solved. And yes guys, we are making progress. We have done quite a lot of medium as well. Now we'll move on to our next problem and see you guys in the next video. Please like, share, subscribe. Bye bye, see you in the next video.